Under the topic nonlinear partial differential equations, here we have problem 12 under standard type 3. The question is solve py plus qx is equal to pq. So we observe that the given question has only x, y, p and q. Z is not present. So the given equation is of the form f1 of x comma p is equal to f2 of y comma q. That is, we have to gather all the x and p terms to the left and all the y and q terms to the right of this equation. In order to do that, first what we shall do, we shall rewrite this equation as py taking this pq to the left minus pq is equal to taking this qx to the right, we get negative qx. Now if you see, p is common in these two terms. So take p common. So y minus q will be equal to negative qx. Taking this x to the left, it comes to the denominator. So we have p by x to be equal to negative q divided by taking this y minus q to the right, it goes to the denominator. So we have y minus q. Now if you see, we have gathered all the p and x terms to the left and all the q and y terms to the right, and this has to be equated to a constant a. Now each of this will be equal to a. So from the first one, that is p by x is equal to a, we obtain that the value of p is equal to ax. And from by equating this, that is negative q by y minus q is equal to a, we get have this negative q as it is to the left and take this y minus q to the right. So what we will get is negative q is equal to a multiplied with y minus q. So from this we have minus q to be equal to ay, and minus a multiplied with q is aq. Taking this aq to the left, we will have aq minus q is equal to ay. Now we see that q is common in these two terms, so q can be taken. So we will have a minus 1 to be equal to ay, and therefore the value of q from this will be equal to ay divided by a minus 1. We have got the value of p and the value of q. We shall now substitute these two values in dz, which is equal to p dx plus q dy. Now dz will be equal to, what is p? P is ax. So ax dx plus q is ay divided by a minus 1. So ay divided by a minus 1 dy. We shall now integrate on both the sides. So integrating on both the sides, we get the integration of dz is z, which is equal to, and integral ax dx, so a is a constant, integral x dx is x squared divided by 2, and then plus a divided by a minus 1 is a constant, so take it out, and integral y dy is y squared divided by 2 plus a constant of integration b. So this is the required answer. We can leave the answer as it is, or we can also take the LCM of this 2, and so that we get 2z is equal to ax square plus a divided by a minus 1 y square plus 2b it will be, which is again, anyway 2b is also a constant. In general we can write it as b itself. So this is the required answer. So hope you have understood this problem. Kindly follow the next lecture for problem 13 under type 3. Thank you.